So when we are trying to measure the efficiency of the program, we call it time complexity measurement. That is how the time is changing with the increasing number of data items. And we are actually interested in plotting a curve showing how that execution time of the algorithm is changing with increasing number of data items. Now the execution time can change in many different way. It may happen that the execution time is not changing at all, even though the data items are increasing, the number of data items are increasing. It may change almost linearly with the number of data items. It may change following a square of the number of data items, like 1 second for when there are one data item, but your program is taking 4 seconds when there are two data items, and 16 seconds when there are four data items, something like that, following a square. So uh, so a small example can clarify the concept. Uh, well, just consider these small examples. So this is the same example that we have used in the previous video. That is, calculate the sum of all the integers between 1 and n. Well, in the previous video, we have used a constant number, that is 1 and 100. But here we are just trying to make it generalized. Instead of 100, I have used n. So let's say there are n numbers and we want to calculate the sum between all the integers of all the integers between 1 and n. So the first solution, if you consider, keep on adding like 1 plus 2 plus 3 plus 4 plus 5. So this one actually, the time for this logic, this solution 1 logic, will increase kind of linearly with the number of data items. That is, if you take 3 seconds to add three different numbers following this way, you will take like 30 seconds to add 30 different numbers, or 40 seconds to add 40 different numbers, or 100 seconds to add 100 different numbers. And it may happen like you got 1 million different numbers, and at that time you have to spend 1 million seconds. So the in summary, the time taken is increasing almost linearly with the data number of data items you have. But now consider solution 2. What it is doing, it is just using one small single formula to calculate the sum. So what is happening here is, even if you have like 1 million element, so you may have like 10 elements, you may have 100 elements, you may have 1,000 elements, you may have 1 million or 1 billion elements. It does not matter how many data items or data elements you have. The time taken is for the solution 2 is always same, like this horizontal to x-axis type curve. So and since this one is always constant, the time taken, and irrespective of the number of data items, of course the solution 2 is significantly more efficient. So that's the broad overview of time complexity. It's all about plotting the execution time, or just showing how the execution time is increasing for your algorithm when the number of data items is increasing.